The Philippines is the global epicenter of marine shorefish diversity and is the most anthropogenically threatened marine region. Coral reefs support around 20% of total marine fisheries production. Fish provide 67% of the protein requirements and the livelihood basis for 5 to 6 million Filipinos. With more than 1 million municipal fisheries overexploiting and degrading the habitat of shallow marine waters, the potential of annual fishery production of Philippine coral reefs of 350,000 tons was reduced to 177,500 tons by the 1990s. Detecting biodiversity changes is problematic since long-time series data are scarce. Whatever the scale, the average reported date of extinction has lagged 53 years behind the last sighting of an organism. Marine extinctions may have been underestimated because of low detection power. There is an urgent need to fill the information gap in data-poor situations. Alternative information sources, such as Fisher's Knowledge, may provide data on temporal catch trends. Such traditional ecological knowledge has, in combination with other data, demonstrated the declining status of Chinese bahaba, revealed the local disappearance of giant bumphead parrotfish in Fiji, and led to the conservation status of Gulf grouper being reassessed in the Gulf of California. Theoretical and empirical analysis show that large-bodied, slow-growing, and late-maturing species are more vulnerable to depletion than smaller species. Life history and ecological traits may be used to determine the threat status of fish species. At Pamilacan, 58.1% of the fishers used hook and line. 24.2% used gill net. 6.8% used spears as fishing gears, while 11% are undecided. At Balikasag, 55% of the fishers used hook and line. 23.6% used gill net. 16.4% used spears as main gears, while 5% are undecided. All fishers considered reef finfish as their primary target fish. 42.9% of the Pamilacan respondents, while 65% of the Balikasag respondents still try to fish even if there were no catch on previous trips, primarily because they still require fish for their own consumption. At Pamilacan, at least one of the 5 finfish species were mentioned by 25 fishers as missing from catches in 1980s. 63 fishers reported not having caught at least one of the 7 finfish species. Some fishers had not caught Alectis ciliaris since the 1960s to the 1980s. Scarus goban since the 1970s to 1980s. And Alphareus furca and Alphareus rutilans since the 1980s. At Balikasag, Alectis ciliaris was rarely caught in the 1970s and missing from catches since the 1980s. Trichiurus species were abundant in 1950s to 1970s, but were missing from catches by the 1980s. Sphaerena flavicauda and Scomberoides lysan were mentioned as missing from catches since the 1990s. Serranoceritus latus since the 2000s. Naso vlamingi and Tunus albacares since 2007. Among the species families, the Carangidae family had the most disappeared species, followed by Scombridae. Serranidae and Lutjanidae each had 2 disappeared species. The rest of the families each had 1 disappeared species. Regarding the finfish's length, 12 of the species no longer caught at Pamilacan and Balikasag had a range of 110 to 384 centimeters total length, while 7 had a range of 60 to 100 centimeters total length. The maximum body size range, 100 to 149 centimeters, has the highest number of disappeared species. Among the species that had disappeared, Alectis ciliaris merits more attention because it was found to be no longer caught by 51% of the Pamilacan fishers. It shares very high intrinsic vulnerability only with E. bipinulata and G. unicolor, yet it was not evaluated under the IUCN Red List system. The IUCN Red List has not created a group of assessors or evaluators for karangids. Yet there were 6 karangids among 21 species that disappeared from the catch at Pamilacan and Balikasag. Another species of concern is Epinephelus lanceolatus, which 10 fishers identified as missing from catches since the 1990s. This is the largest reef-dwelling finfish in the world. It is rare even in unfished areas and has nearly been extirpated in heavily fished areas. It is among the grouper species most targeted for the live reef fish food trade focused on Southeast Asia. Ecology and behavior constitute another important link to fish population decline. The tendency to gather into large, easily fished spawning aggregations results in greater risk of population depletions. Change of gear was unlikely to be the cause of species not being caught. Coral cover changes were also an unlikely reason for species disappearances. Using multidisciplinary approaches, including use of data and analysis from traditional ecological knowledge, can make fishery managers and biologists' reasoning defensible, and thus help improve the accuracy of conservation action and fishery assessment in the Philippines and elsewhere. Outcomes of this study can serve as additional information for bodies such as the IUCN in assigning threat status to species. Fisheries data collected by human recall may help elucidate long-term changes in reef fisheries and can provide a springboard for studying historical declines and local extinctions at the species level that may otherwise be inaccessible to scientific methods. The Darwin Initiative Program, assisting countries which are rich in biodiversity but poor in financial resources under one or more of the 3 major biodiversity conventions. Convention on Biological Diversity, or CBD. Convention on International Trade in Endangered Species of Wild Flora and Fauna, or CITES. Convention on Conservation of Migratory Species of Wild Animals, or CMS. Through the funding of collaborative projects which draw on UK biodiversity expertise. Purpose of the project: identifying vulnerable marine finfish species in 5 key marine biodiversity areas such as Palawan, Verde Island Passage, Danahon Bank, Bohol, Polillo Island, and Lanuza Bay, Surigao del Sur. Modeling changes in the abundance of reef finfish families and fishery target species for 5 key marine biodiversity areas. Enhancing capacity of local government units and people's organizations for local resource management in conservation sites. Reconciling conservation needs with sustainable livelihoods. Making local, national, and international policy recommendations. The team: Professor Dr. Nicholas V.C. Polunin of Newcastle University, School of Marine Science and Technology, United Kingdom. Project Leader: Dr. Margarita N. Lavides of Environmental Science Department, Ateneo de Manila University, Philippines. Project Co-Coordinator: Mr. Gregorio Dito de la Rosa, Senior Staff, and Ms. Erina Molina, Junior Staff of Haribon Foundation. Dr. Selina Steed, Dr. Steve Rushton, and Dr. Eileen Mill of Newcastle University. The project duration will be from April 2012 to March 2016. Potential project partners: University of the Philippines Marine Science Institute, or UPMSI. Conservation International, or CI. Palawan State University, or PSU. University of the Philippines Mindanao, or UP-Min. Project Seahorse Foundation for Marine Conservation, WWF Philippines, Institute of Social Order, or ISO, Bureau of Fisheries and Aquatic Resources, or BIFAR, National Fisheries Research and Development Institute, or NFRDI. Other institutions who own historical data on fish and fisheries from Fisher's Knowledge, Underwater Visual Census, and fish landings and are willing to share the data with the Darwin Project. Policy recommendations to protect threatened fish species means identifying locally extinct fish species and modeling abundance trends over time, both of which are not easy tasks. Even with Newcastle University, Ateneo de Manila University, and Haribon Foundation helping hand in hand, we still need your support. By sharing with us your current and historical data in any of the 5 project sites, you help ensure the success of this project and the conservation of marine life, especially in the light of climate change and threat to food security.